Hello, welcome to Ms. Rojo's Math Time. Today we're talking about subtracting fractions. Now, fractions have two parts, the numerator and the denominator. And if you don't know where the numerator and the denominator is in a fraction, you can think about this picture. The numerator is Norman. Norman is sitting on top of a donkey. So remember Norman and the donkey. He's riding the donkey. And so the number 1 will be our numerator. The bottom number will be our denominator. There's some fraction misconceptions that I would like to talk about. For example, whenever we have subtraction in fractions, we do not subtract straight across. The answer here would not be 4/8, and the answer here would not be 6/12. What you have to do is first you have to lay out both fractions represented, because today we are using representations, and find a common denominator, and finally the last step is to subtract. So fractions, ooh la la, fractions have a whole, and what that means is that there's parts and there's a whole. This one and this is a linear model, and this is an area model. With these tiles, we can see that this one is a whole, and these are the parts of a whole. So this does not mean that there's 5. If you have 1, 2, 3, if you have 3/5, that does not mean you have 5 wholes. It means that out of the entire thing, it is divided into 5 pieces and only 3 are affected. So let's pretend that you have a pizza. If you have a pizza, you have 8 pieces, and that is the whole pizza. If you only eat some parts of a pizza, those are the parts. See, if you eat 2 parts of a pizza, that will be the fraction. The whole is the entire thing, and the denominator tells you how many pieces there are, like into how many pieces it is divided, and the numerator tells you how many are affected, shaded, eaten, etc. You get the point. Now let's talk about the math problem and the objective. We will solve problems with fractions using pictorial representations with denominators of 3, 4, 6, and 8. Ms. Rojo had 3/4 of a pizza. She ate 5/8 of the pizza. How much pizza does she have left? So let's remember our steps. Represent with a linear model. We're going to use a linear model, and remember this is the whole, and for example here we don't have 4 pieces of pizza. I mean, that's not like we don't have 4 pizzas. We have a whole pizza that is divided into that has 4 pieces. For example, once we read our instructions, our steps, we can begin. Step number 1, lay out both fractions represented. Okay, so I have 3/4 represented, and I have 5/5 represented. So this is the total pizza that she had, and this is how much pizza she actually ate. And this is the whole. So if you can tell, she didn't actually start out with a whole pizza. She only had some pieces of pizza. It is very important to line up your linear model. And now we can find a common denominator. How are we going to find that? So let's see. Can 4 be our common denominator? See, it's too big for 1/8. So if we did have 3, it would be too many. So that one can't be it. What about 1/8? Can 1/8 be our denominator? And the answer is yes, because it lines up with 1/4. So 1/8 can go into 1/4. So if we turn these 1/4 into 1/8, it would look like this. Okay, so now you see we have 3/4 represented with 1/8, and now we can subtract. So 1, 2, 3, 4, 5, 6, 6/8 minus 1, 2, 3, 4, 5/8 equals 1/8. That would be our answer. Our answer would be 1/8. Now if we look at an area model, this is our 1/2, this is our 3/4, and this is our 5/8. Now how can we figure out, can 6 be our common denominator? The answer is no. Can 8 be our common denominator? And the answer is yes. It fits into both without being too much. You see, 1/4, it would be too much for it. So we can subtract.